Anritsu has well over a dozen handheld products for testing in the field. They all are battery powered. We have a number of different platforms. Two are shown here. This is economy, this is the mid-range. The newer mid-range product has the addition of software demodulators or software options that allow it to serve different markets. The spectrum analyzer family is used to measure signals, and they have traditionally just been a simple amplitude versus frequency display and not customizable. With the advent of digital signal processing and faster CPUs, we now can put very specific software inside to measure the digital radios that are emerging, like the cellular standards, CDMA, WCDMA, LTE, and WiMAX. All those now have specific needs, and we have software to match that. So that's a trend that's new in the spectrum analyzer business. The phase noise, which is a core capability of any spectrum analyzer, allows you to resolve signals and have good sensitivity. The phase noise is exceptional. The range of bandwidths and amplitudes is unmatched, and the choice of demodulators is unmatched. So we really have a much more powerful platform than I think any of our competitors. The mapping is more enhanced. The analyzer is more powerful, so it's more sensitive. It has wider frequency coverage, so this goes to 6 gigahertz and this stops at 1.6. So it's a more powerful product. And today, I'm talking about one new option of the many options available, which covers the land mobile radio market, which is this two-way radio market that's used by public safety, by taxi cabs, by utilities. So these two-way radios are ubiquitous and have been around for many, many years, and now they're, with an FCC mandate to narrow band, they're all changing to digital. To use these in the field, certainly they're battery powered, so you could do bench measurements on the tailgate of a truck, but also all of our models have a GPS option that allow the measurements to be tagged with the location and the time. And we've had a recent addition of the ability to make measurements and map them directly. And how that works is we go into the mapping mode and the data goes right to the memory stick, and then the data then is mapped directly to Google Earth, and you can see power measurements or modulation measurements or bit error rate measurements over a mapping area. So you drive around in your car with one of these with an antenna on the roof, and you then can verify that the coverage of your transmitter is as you expected. The instrument directly writes the measurements and the location onto a USB memory stick. You then just take the memory stick over and put it in the PC, and in this case the PC has Google Earth installed. The file format is ready for Google Earth, so now you see individual push pins for each measurement that's made and the values for each. So coverage mapping is more important with this trend to digital. We then help people verify the reason that their coverage is inadequate and maybe look at the cause for that, but either it's multipath or it's just lack of signal. 700 megahertz spectrum is quite concentrated with a variety of users, from the very high power narrow band signals from public safety to the broadband LTE types of signals. And any concentration on a hilltop or in a city, if any of the transmitters have a flaw, it's likely that the signals will either mix or splatter over into the other services. And I think the worst fear is the splattering over into the public safety spectrum. So it's a growing problem, and our products with their high spectral purity and wide dynamic range are probably the best products to go out and hunt down these kinds of signals. We have a lot of features, including spectrogram displays and peak hold and lots of capability to help people hunt down these maybe pulsed or intermittent signals. The public safety environment is, of course, very critical to being able to communicate. There's lives at stake, and there's a lot more care taken relative to cellular to being sure that their staff can always communicate. So there's more money invested in verifying the coverage and hunting down problems to be sure that they can communicate and they can do the task that's at hand. A special purpose digital radio test set could start at $40,000. So I think a public safety entity can reduce the number of those kinds of products and get most of their work done with a more general purpose product. Okay. Plus have the ability to do this coverage mapping and to do the general purpose interference hunting that they are going to see an increasing need for. The base unit is around $8,000, and as I said, there are many options available depending on whether you're interference hunting or you are looking to measure the coverage of your signal, or in fact you're wanting to do detailed adjustment of a digital radio. So the options vary from $1,000 to $3,000 each. If someone would like more information about this product or any of our family, just go to the Anritsu.com website.